digital agriculture. Very excited to see you all here. Today we have our 103rd webinar in the What's Cooking Digital Agriculture Learning Series. This is the series where we invite thought leaders, innovators, digital technology and service providers to share their innovations in technologies. All our webinars are available on the World Bank Open Learning Campus, as well as on the YouTube channel. And my colleague Sunil will post the links to both of those repositories in the chat. Just a few comments on housekeeping. Please keep yourself muted, your microphone's muted, to remove the background noise. And also, there will be a Q&A session after the presentations and after discussants intervene. So please share your questions in the chat. So you can find chat at the bottom right of your screen. So our colleagues will collect the questions, and we can use those for the discussion at the end of towards the end of the webinar. If you do have some clarification questions, please do post those as well, and speakers might choose to answer those right after their presentations, if those are clarification questions. If those are more questions that require more in-depth discussion, we'll keep those for the end of the webinar. So today we have an important and exciting topic to discuss about harnessing Earth observation data for monitoring crop conditions around the world, and doing so at both global and national level, and bringing those two levels together. So we've all seen the quiet revolution that Earth observation data is doing in agriculture. And the satellite data related analytics have been revolutionizing crop monitoring. And with the new sources of high resolution data, it's possible to monitor land use and create crop maps, even in countries where smallholder farming is predominant. But what we are also seeing at the World Bank, so from one side, we're seeing this, revolution and transformation that Earth observation data is bringing. But from the other side, what we see is the lag of adoption of these new technologies and data at the country level. And not always the highest capacity to operationalize the use of this new data and methods. And while the countries no longer need to develop full-fledged data ecosystems nationally, because there are large global and regional scale monitoring systems that exist, still to develop national level recommendations and response systems, we still need understanding of the country's specific conditions. And in today's webinar, we will explore an example of the symbiotic partnership between one of the largest crop monitoring systems globally, CropWatch of China, and governments of Madagascar and Ethiopia in developing actionable crop monitoring at the national level. This work and partnership was developed in the context of the grant that was generously provided by the China World Bank Partnership Facility. So with that, let me have a couple of words on the run of the show. So today we'll hear from three speakers: Dr. Miao Zhang from the CropWatch team. He will introduce CropWatch Cloud and the related smartphone apps. Then we will hear about two country-level examples from Melkamo Demelash and Tahiana Rajasari Malala. And then the presentations will be followed by the reflections from our two discussants, Andy Nelson from the University of Twente and our own Lorraine Ronke of the World Bank. With that, let me introduce our first speaker and invite him to take the virtual floor. We have extended bios available in the program, so I will not spend much time on going through the entire bio to save us time for the discussion and the presentations, and have a bit of the truncated bios for everyone. So Dr. Miao Zhang is Associate Professor at the Chinese Academy of Sciences and a key member of the Crop Watch team. Dr. Zhang also serves on the Executive Committee of the GeoGlam flagship and co-leads the Joint Experiments for Crop Assessment and Monitoring Initiative. Miao, the floor is yours. Thank you.
Thank you. Thank you for your introduction, Chair. Let me share my screen. Okay. Does everyone see my screen?
Not yet.
It's okay now?
Still no.
Not.
I wonder if
No?
you should try again.
Sorry.
Sunil, do you have presentation on your side? As
What
a
about
backup, we
now?
can try to load that from our side.
Yes, I have the presentation, Katrina.
Would you like to try sharing that from your side?
1 second.
We'll try that. Okay, I think
Is
we
it
have
okay
it from
now?
you. Yes, it's coming up. Here it
Okay,
is. We
sorry.
have it. Yeah, go ahead.
So, good evening, everyone. It's really my pleasure to be here to introduce our efforts, our system Corporate Cloud, which is a global agriculture monitoring system using remote sensing and to do crop monitoring to provide information for developing countries. In my presentation, I will also talk about the two smartphone apps we have, which contribute to the data collection and to support the crop monitoring. So I also want to address some background, although the moderator already mentioned this. Nowadays, the human beings is facing severe food security because of the climate change. There are also conflicts and some other factors that worsen the situation. And if you look at the hunger map provided by World Food Program, you see that most of the countries that are suffering food shortage are in African and South and Southeast Asia. And those countries are either high population or high growth of the population, and also their lack of capacity, not only the hardwares, the infrastructure, but also the technologies and softwares to do the crop monitoring. So they don't have um, um, accessibility to those food information, so that they don't have science-based, they cannot make science-based decisions related to food security. And this has created a lot of problems. In the past, China also suffering the same issues. Like we can track to 1998. That year, there are severe flooding occurred in China, and the statistical division of the National Statistical Bureau, they announced a report saying the flood will significantly reduce the crop production, while we use remote sensing data to monitor crops, and with our monitoring, we find only limited croplands are affected by the flood, mostly along the rivers and lakes. But the high rainfall also provides sufficient water, which are benefit for other regions' crops. So according to our monitoring, the crop production that year actually not decreased but increased compared to the previous year. So we submit our remote sensing based estimation to the central government, and they take our information and make corresponding decisions like um, provide more support to build the warehouse to store the additional crop production. So that year, actually, our information contribute to the central government to make those decisions, timely decisions, to either to store the crops after the harvest, and also they take our information to support within the country crop transportation. Like some region in the north, there are high production, and the government decide to transport more production from that region to other regions where there are significant decrease of uh, the crop loss. So these really provide very timely information for the government to make science-based decisions. So these are our experience. Since then, the government has supported us several program and projects to enhance the crop monitoring systems. Up to now, we already have 7 big upgrading versions of the crop watch system. At the beginning, we have separate modulars, and then in 2008, we developed a whole system that integrate all different components together and use a whole database to manage the system, to manage the data. And in 2013, we deploy our whole system to Alibaba Cloud, so that there's no need for us to maintain the hardware, the disks, the computer, supercomputers. But the Alibaba Cloud, they provide such infrastructure and services for us. And since 2017, we provide cloud services for users like a colleague from Madagascar, from Ethiopia, and more than 20 other developing countries. With the cloud services we provide, they can access to free and open crop-related information for their own country. And recent years, with the development of artificial intelligence model, we embedded different models into our system to provide more advanced remote sensing processing, and provide more advanced crop information. And since last year, we package our components to different APIs so that users can integrate different API together to do their own monitoring. So these are the whole upgrading history of the system. Currently, the CropWatch Cloud mainly relies on remote sensing data. It provides different type of indicators, including the climate information, agronomic information, farming practices, production, disaster or stress, and also provide early warning indicators. We also have our own baseline datasets like a cropland mass, irrigated land mass, cropping intensity, etc. And before this year, we released bulletin every 3 months, but since this year, we want to provide more timely information for the users. So every 2 months, we release a bulletin to monitor global crop condition, and to provide outlook for the 4 major crops: wheat, maize, soybean, and rice at global scales, and the major agriculture production producing countries. And every year we also integrate different kind of like a quarterly bulletin or bi-month bulletins together to formalize annual thematic analysis. And all those reports are freely accessible by all the users. And we have very limited human resources in the team. as we are a research institute. So most of the data processing are automatically done. And so with access to the data sources, we can access to different type of remote sensing data. And by the standard package of the algorithms, those remote sensing data could be converted to the crop related information in different format, like using chat format, by providing images or tables or maps, interactive maps, so that even users with no remote sensing background, they can access to the information. And we try to provide those information as a kind of a decision-ready products. So these are our philosophy to provide the information. So I also have a couple of slides to briefly talk about the methodology, but maybe it's too technical. But I want to introduce you that our system provide information like crop areas, like how many hectares of maize, wheat, and rice and soybean for each country or different provinces of the major countries, using different type of methodologies, either geostatistical approach or machine learning based crop type map, which you can the system provide a visualized information to show where maize, rice, different crop types are cultivated. Like this one, this is an example of the 10 to 30 meter high resolution crop types across Northeast China, and where maize, soybean, and rice are main crops over there. And so with the interface, the user can zoom in and zoom out to see the detail level of the different crop types. Like this is zooming to very local region where orange color are soybean field, blue color are rice field, and green color is maize field. So with this kind of information, the decision makers, they can track the changes across the years of the cropping systems and also statistical area of different crop types. For the yield model, we also integrate different type of methodologies. Mainly, we integrate 4 type of methodology, depending on the cropping systems or whether the fields are irrigated or rain-fed. So we integrate those 4 different type of methodologies together to provide more reliable information on the yield prediction for different countries. For rain-fed areas, mostly we could simply rely on regression model, but for irrigated or high-density cropping systems, we will use other methodologies like biomass and harvest index model, where we can track the cumulative biomass and then convert it to the weight of the grains to estimate the crop yield. So these are very brief introduction of the methodology. And with those methodologies, the crop yield and production map at global scales is also available in the system. This is a rice yield map across the globe, and there are also available information for other 3 major crops, in a similar or format. To support this kind of crop monitoring, we provide 2 smartphone apps. One is FieldWatch, the other one is GVG. So FieldWatch is developed to collect the yield data without cutting the plants, by using artificial intelligence technologies to detect the number of kernels per square meter, the number of seeds per kernel, and the size of kernel with by integration of the crop variety information, we can estimate the yield without destroying the plants. GVG is another app to collect the crop photos during the field survey, and then artificial intelligence models were employed to detect what type of crops are cultivated in each photo with and linked with geolocations. So those data could be matched with remote sensing data to estimate crop area to map crop type across different regions. Behind the system, we also have artificial intelligence model. Like recent years, we developed a large language model and to provide suggestions for the farmers when they take a photo of the plants. And like this one is a leaf with diseases. And then by using the large language model, the tools could could identify what type of disease or pest is, and then provide some suggestions for the farmers, like what pesticides or herbicide to be used to reduce the negative impacts. So even the small scale farmers, they could use the tools and use this kind of innovative technologies to benefit, to help them to better manage the field. And the large language model is not only embedded to provide this kind of small scale information, but also used to interpret the remote sensing based maps and graphs and tables to automatically generate crop analytical text. Like for each country, it just take less than 1 minute to automatically generate crop analysis reports. Of course, it is not perfect. The users still need more some modification to or double check whether it is reasonable of the analysis. But with more users involved in this interactive process, the model will provide more reliable analysis. And these are some cover graphs of the released bulletins in the past. You can refer to those report in CropWatch website and also China Geo website. So this is the last slide I want to show to you. This is one of the unique features that CropWatch Cloud offers. It allows users to self-customize crop monitoring so that the user could select different components and to target different regions using different indicators, using their own data to generate high-resolution crop type maps, and the result could be downloaded to the user side. They could use it internally. So these are some unique features that we offer. And in the future, we also want to provide edge computing technologies so that users can use their own infrastructure and maintain their data on their own site, but using our model to process the data to generate crop-related information to support decision makings. So the last slide is some existing activities we've been done with the support of World Bank. This capacity development project supported by World Bank started in August last year. We have 2 weeks training in Beijing, and then we conduct in-country training in Ethiopia and Madagascar separately. And we travel to their country and train them in the field to train them how to collect the data to support the crop monitoring. And with several training, they managed to use the system. I'm sure Tahiana and Malcolm will show detailed information. And thank you for your attention.
Thank you very much, Dr. Zhang, for this inspirational talk that highlights, the advances in the technologies and in the data and their potential to monitor food security and creating just-in-time, crisis response systems. Appreciate that. And now we will transport to Ethiopia. And I would like to invite our next speaker, Melkamu Demilash, who is a researcher at the Ethiopian Institute of Agricultural Research, with specifically at the Directorate of Climate, Geospatial, and Biometrics Research. In this capacity, he leverages his expertise in GIS and remote sensing to support agricultural research and development initiatives. Malcolm, the floor is yours. Thank you.
Okay, thank you. Can you see my slides?
Yes, we can see your slides.
Okay,
There
thank you
is
so
some
much for giving.
screen. Oh yeah, no, oh fine, good.
Okay, thank you for giving me the chance to present for this event. My name is, as you introduced, Malcolm Damallash. I'm from Ethiopia. By profession from GS and remote sensing. So as my outline in my presentation, it have its own background, achievement, challenges, and there's a way forward. At the end of the presentation, the way forward will be available. So when I start from Ethiopia at the glance, is the background of Ethiopia. As you know, Ethiopia is very fragmented land, and the base economy for income is only 85% of the economy based on agriculture, so that it is a land of origin and the center of biodiversity, or the 7,000 higher plant species are available and the 12% are endemic. And as a whole, since the topography of the country is very complex, and the base of the economy is agriculture, to detect the agricultural pattern in the country, remote sensing is so the most application thematic area, and remote sensing technology is very interesting to detect the agricultural pattern across the country, so that the pattern of the landscape of the Ethiopia is very complex. So the soil types across the country is so also very dynamic. So the remote sensing is very needed to detect all these things. And as achievement from the training of crop watch system to agricultural crop monitoring and prediction, we have conducted field segmentation, crop type classification, and yield estimation. So when I talk one by one, we have conducted a training, as Dr. Niao introduced, 3 times, 2 times in Beijing, 1 time in country, in Ethiopia, which means. So as field segmentation was conducted at farm plot delineation. This was conducted, first we do have Google satellite image, and separately we could digitize the agricultural farmland in the entire of districts, and then we try to combine or link each digitized agricultural land of the area of the district. Then it looks like this, as you see from the screen. By the same thing, we could classify the crop types across the regions of Ethiopia. As you know, or here, Ethiopia have just by now 11 regional states. So we took sample data from the regionals, and we could try to classify for zonal levels, as you see from this, by using the crop type data of a sample taken from the ground. Then we uploaded the sample data to the system, and then we tried to classify the crop type available in zonal level as a sample. By the same thing, we also classified a crop type in country level by GVG data. As Dr. Miao introduced, GVG that can collect the sample data from the ground, and we could collect sample data from nearby Bishoftu, which is nearby Addis Ababa. Sample data we collected from there and uploaded the data from the ground, and classified the crop type across the site of plot of farmland. By the same thing, crop type classification from sample data was calculated for regionals. By the same thing, we do it for zonals and the regionals, and even we try to calculate the area coverage for each crop type across the regional states of Oromia region. And also, as I have said you, we have digitized agricultural lands or croplands across the entire of the district of some area of so-called Tole district in Oromia regional state. We digitized the farmland. Then we classified that area as a cropland. Then we combined the digitized the agricultural land with secondary data sources of crop watch system. So then we try to compare which one is more precise than it is. For example, if you see from the screen, on the B, we have digitized the cropland from satellite image. On A, we already used from the secondary data set. In B, the agricultural land which was digitized by Google satellite was very precise than the secondary data of A. This is the overall wheat irrigation yield prediction of Ethiopia. If you see wheat irrigation at the national level from the left side of the map at the corner, we have tried to capture the national irrigated wheat across the Ethiopia. And then we have downscale to some regional states, then to districts. We have this activity at Ethiopian Institute of Agricultural Research. Then we try to customize to the system of stopwatch. Then I try to estimate the yield prediction for wheat irrigation in 2024, which is last year, and the 2025, which is just by now. It is not harvested yet, so that thing is under calibration. So if you see this map, this map is generated from a crop watch system, which was uploaded. The cropland mask is uploaded to the crop watch system. Dupti, Asaita, and Afambo are 3 districts in the entire of the study, so that we try to detect the irrigated wheat in that area. By now, this thing needed some calibration data from the ground, so that it is under process of under calibration data. The data on the ground is just collecting by now. We can verify the data as the yield estimated by now. Here is, as Dr. Miao introduced you, this is a GVG data which we collect the calibration data from the ground by using the mobile app. It can capture, it can analyze the weather data from the ground. The grain yield can be estimated during the maturation of the wheat irrigation by now. Now the area of the cropland is the crop of wheat is not harvested yet, so that we are just calibrating the yield which you get from the crop watch is under calibration. As a dissemination from the whole generation of the output, we do have so far, we have a country analysis bulletin in Ethiopia from the crop watch system. We could detect NDVI time series from the system, and the phenology of each crop type can be generated from crop watch system so far. By the same thing, we do have our own advisory dissemination system, which means livestock water point monitoring system is here in my institution, which is owned by Mr. Liune, and this was conducted in rangeland for pastoral to know the water pond status time by time, and it can be disseminated by the system. By the same thing, we trust advisory system also conducting under process by Cambridge with integration of Cambridge University, CMIT, Ministry of Agriculture, AR and ATA by Mr. Tadese. We trust advisory system, which means risk assessment from the ground with the survey or forecast in Ethiopia is just under conducting. The key to success as a challenge, we do have a problem of coordination, which means different experts have their own capacity or potential, but there is no coordination. Building partnership and collaboration is the one challenge. And also there is a problem of infrastructure. Digital infrastructure is also there. High processing computers is also there. Knowledge, there is a little manpower in GSM expert. But the same thing is the data collection, analysis, visualization, the data sharing system is also another challenge. And the building database, we don't have a central database system which can disseminate among each expert. But the same thing, we do have finance and technology is also one challenge, but we are on the way to customize crop watch by now. Opportunity, we do have some opportunity and we do have some way forward at the end. And as opportunity, there is a development plan as a country level. There is a development plan which we call Ethiopian food FSRP. We call FSRP food system research program. Resilience program is another opportunity which is under conducting for food to improve the food security, and it is supporting in financial aspect by now in the country. There is 10 years development perspective plan. This is also one kind of opportunity. There is also initiatives in digital agriculture in Ethiopia by now, and also under digital agriculture there is agriculture pillars, which means digital agricultural pillars also there. National ICT policy is also under developing. Digital agriculture extension advisory service also on the way. These all are just considered as an opportunity as the way forward in remote sensing based crop monitoring and yield estimation for food security. We do have just this is underway, signing the memorandum of understanding with AirCast and the partnership for partnership. And there is also awareness creation experience we gain in China to develop our skill. Now we need more. And also there is publication crop watch bulletins, or also as I have said you, we try to publish that one also. Establishment of national working team, this also we need as a way forward this one. And the calibration, we do have some result by now, and but it needs some calibration on the ground with digital advisory systems. Just we got application tools by GVG and as I have said you by field watch, we have this one option, and we have to stay engaged in that one. There also verification with ground truth data for crop watch system, and again national database system, which means a big data analysis for food security gap analysis. We have to have this also. Institutionalization, the system of crop watch should have to be centralized in our country. We think in that way, so that we do have this thing as way forward. And there is also a possibility of collaborations with different sectors in Ethiopia and else in other countries. For example, Ministry of Agriculture, Ethiopian Space Science and the Geospatial Institute, Ethiopian Statistical Service, Agricultural Transformation Institute with CropWatch. We do have some collaboration. By now we are on the way to integrate this all. And finally, we would need to acknowledge the World Bank. First, they gave us the chance to be trained these all systems, and would improved our capacity by now. And the same thing, AirCast, which means Aerospace Information Research Institute or Chinese Academy of Science, also we would acknowledge them. They have been with us during training in aspect of technical issues and supporting us. CropWatch, GeoClam, and Ethiopian Institute of Agricultural also acknowledge in this system. And finally, I would like to thank you all.
Thank you very much for this insightful and resourceful presentation that highlights the successful outcome of the partnership between the Ethiopian government and CropWatch. It's very exciting to see, and I appreciate you particularly mentioning also your thinking around the way forward and how this partnership can be scaled up and sustained over time, because at the end of the day, this is the goal. And I look forward to our discussion at the end of the session to touch upon some of these things, to see how we also from the World Bank can support scaling up this work in Ethiopia and supporting the partnership. With that, let me move to our next speaker, Tahiana Rajasarima Lala, who will talk about the experience of partnership between CropWatch and Madagascar. Tahiara is a geospatialist specializing in remote sensing and geographic information systems. She has extensive experience in agriculture and environmental management, working at the Center on Geoinformatics Applications and Rural Development inside of the Ministry of Agriculture and Livestock in Madagascar. Tahiana, over to you.
Thank you very much for this introduction. Hi, everyone. Thank you for giving me this opportunity.
Excuse me, Tahiana. We don't have your screen, so you may want to share that, your slides.
Sure. Yeah.
Sorry.
Okay, they are coming up. Perfect. Yeah, if you could just make the full screen. Yes. Thank you.
Okay. Thank you for this opportunity to speak with this for this webinar session about harnessing data for just-in-time analytics and action for global food security. For Madagascar parts, we applicate a CropWatch platform for rice mapping and yield predictions. This is the outline of my presentation. There is the introduction and the objectives of CropWatch, because we work with the CropWatch platform. That's why I put the objectives. And I will present also the workshop in Madagascar. And we will see the application of this CropWatch platform during the training as we did. First of all, let me tell you, where is Madagascar? Madagascar is on the southeast of Africa, and it is one of the fourth largest island in the world. It is located on the southeastern of Africa, and Madagascar is characterized by a great diversity of landscape and divided on 23 regions. Then let us know what are the objectives of the CropWatch platform. And their objective is to build capacity in using CropWatch cloud tools to give the pilot country to access the crop information is in Earth observations, techniques, and CropWatch platform, and to enable to do respective national or subnational crop monitoring on our own in real and near real time, to promote resilient agriculture practices by integrating geospatial information from crop monitoring. To summarize those objectives on improve food security monitoring. Madagascar has a privilege of hosting the CropWatch team and the World Bank team for presenting, sharing, teaching the powerful tools for this CropWatch platform. During the workshop, the CropWatch team share to us what is the advantage to use the remote sensing data and how to use the software like as Dr. Mios presented before, like using FieldWatch and GVG software for collecting the data. And it's an opportunity for Madagascar participants to have the CropWatch expertise on this on using the remote sensing data. So we have I have to thank you all the bank and CropWatch team for giving us this biggest opportunity, because it's not only for sharing, just for sharing or presenting, but they will share us how to do the survey and how to practice and how to collect the data for the participants. So at least the participants felt like it's very useful to use this platform, CropWatch platform, as long they work. Now, what are the application of CropWatch platform for we Madagascar participants and on the both workshop in Beijing? We choose to do the rice mapping and yield prediction on both regions. As I said before, like Madagascar divided on 23 regions, and we choose both regions, Itassi and Vaknakaraj, who placed located on the middle of Madagascar. And both regions also, it's rice production zones than the 16 zones, rice zones in Madagascar. That's why we choose the both regions for applicated the CropWatch platform. Rice mapping. There is a numerous tools inside the CropWatch platform, but we choose to do this rice mapping because rice in Madagascar is very important, takes a more important place on the crop cultivation, and it's a main crops also in Madagascar. In fact, a staple food for the Malagasy people, and it takes an important place for Malagasy population. So that's why we want to have this race mapping, and for us also, we just have the data on this Itassi and Vaknakaraj for calibrate the CropWatch platform to have this rice mapping. So this is the result of rice mapping using a CropWatch platform. And for Itassi also, for rice also, it's a big challenge for Madagascar to predict a yield, a rice yield, because till now, the Madagascar can't predict the yield, or it will help the responsible, the high level for planning with the lack of the rice for funding the population. So it's very important to do this rice yield prediction. So there is a CropWatch platform who did this yield prediction. That's why we use this yield prediction for ITASI, and we compare with the result as we get from the yield prediction from CropWatch, and compare with the real data, and it has some it's a little bit the same the result, so it's very interesting to use this yield prediction with a CropWatch platform using yield prediction. And it's like that also for Fakna-Karaj. Fakna-Karaj also it's a rice region zone, and we did this yield prediction also, and we compare the result for the CropWatch platform and the real result. So it's among the same. So we can use rice yield prediction with CropWatch platform. The biggest challenge with this yield prediction for Madagascar, it's very difficult to have this harvest index, or on this platform they use this the formula like yield prediction. It's equal biomass by harvest index. So we have to find this harvest index for determine the yield prediction. So it's a big challenge for Madagascar also. During the workshop also in Beijing, they trained us for making a bulletin, because it will help the high level for making a decision, and for a crop monitoring. It's better to use this bulletin, because for the bulletin, CropWatch bulletin, use a remote sensing and accurate reference data on crops, cover agroclimatic condition and crop health every 4 months, examine factor at global, national, and regional levels, and report CropWatch estimates of crop protection, and inform of recent disaster events impacting agriculture. So it's very important to do the bulletin for each crops. And during the workshop, we did a bulletin, and we have to do it regularly for Madagascar countries. And inside the bulletin, there is many parameters, as Dr. Mayer explained before, like they has a climate data, agroclimatic data, and the temperature, precipitation. Those parameters is needed for making a bulletin, and for helping the high level for taking a decision, and for crop monitoring also, and for helping the farmers for monitor their crops. So for us, for Madagascar, it's the outlook is like sharing this knowledge, CropWatch knowledge, and experiences gained during the workshop inside the Ministry of Agriculture and Livestock. And we have to expand the work on the 23 regions of Madagascar, because we have we think as it's very easy to use this CropWatch platform to take a decision and to help the technical person for their work. So we have to share it, and we have to apply it also this knowledge during the training. In conclusion, the agriculture sector management is essential for ensure food security, and we thought like remote sensing is very powerful tools for crop monitoring, offering numerous opportunities to improve farm management and ensure food security. Our participation in this training workshop has allowed us to broaden our knowledge and experiences in the field of remote sensing despite the limited time available. So I profit also to thank the World Bank and the CropWatch team, the AirCast, the GeoGlam for giving us this opportunity to attend the data workshop and to improve the crop monitoring in Madagascar. So it's a big challenge for the Madagascar country to do this CropWatch, to use this CropWatch platform because lack of budget and lack of data. We don't have many data to calibrate the platform, so it's a big challenge for us to collect the data on the 23 regions. So thank you for your attention, and thank you for all of us.
Thank you very much, Tahiana. Another rich presentation, and thank you for staying so perfectly on time. Appreciate that. And it was very encouraging to hear about the usability of the CropWatch platform and the partnership. I would like to thank everyone for staying active in the chat and posting your questions, and for Dr. Miao to diligently answer them when it comes to CropWatch. Please do continue to add in the questions for us to have a discussion during the Q&A. I think it would be a wonderful opportunity to kind of investigate how we can scale such partnerships across different countries or deepen them in the countries where they already exist. So now let me move on to our discussants. So we invited, as I mentioned previously, two discussants, Andy Nelson and Lorraine Ronke, who sort of offer their reflections from two different angles. One is on the advances in the satellite data for crop monitoring, and from Andy's side, and then Lorraine's side is on the importance of capacity building at the national level, and then bringing these advances in technologies and strengthening the capacity for the fruitful result. We are about 10 minutes behind the schedule, so I would appreciate if Andy and Lorraine could stay within the 5-minute limit. And now let me invite Andy to the floor. First, let me introduce him. So Andy is the professor in food security and spatial agriculture at ITC, University of Twente in the Netherlands. He's also the chair of the Capacity Development Working Group for GeoGlam. And you can read his bio, and Sunil will kindly post it in the chat, about all the exciting programs and initiatives that he has developed and led. Andy, over to you.
Thanks very much, Katharina, and hopefully you can hear and see me clearly. Pleasure to be on the webinar, and took a lot of insights from those, as you said, rich presentations. There were a couple of things that stood out when it came to the Earth observation technology that had been developed by Meow and his team for CropWatch, and the training and the adaptation of that for specific use cases in Madagascar and Ethiopia. From an Earth observation technology perspective, the things that stood out were the increasing use of AI with remote sensing. So AI-based analytics, accompanied with the cloud computing and the satellite data processing, all allowing you to improve efficiency and do this kind of work at scale, and rapidly take a system that has a lot of common elements, but tailor it to specific requirements, and demonstrating that it does provide the technical and computational support needed for these national scale applications. So one thing that also comes up is the access to data. Access to Earth observation data has been a constraint that's come up in multiple training or capacity development areas, and the access to high resolution and frequently updated data sets. And I think this kind of high performance cloud computing platform takes away a lot of that burden and makes it just simply much more accessible and easy for people to use, because you can overcome the infrastructure limitation. One thing I would say with that is finding the right balance between having these cloud-based platforms and at the same time requiring a degree of national ownership of this. What is the right balance between using a platform that's developed by others and being able to control it and manage it yourself? I think with Mia's presentation, that there seemed to be a way of doing that, but it would be nice to think about in a specific institutional context, what is the desired level of ownership of such systems. I thought what was very exciting was some of the ideas with mobile applications and edge computing. So that kind of gives you some decentralized processing, again, reducing the need for constant internet access, which can be a challenge in a lot of rural regions. So that makes the use of these smartphone apps for data collection and processing, again, easier in some of these different contexts. And when it comes to using the Earth observation information or the field data collection, you want to turn that into bulletins, whether they're monthly or quarterly bulletins. And we know that can be a substantial amount of work, a lot of expert knowledge needed to bring together the insight and the story that matches the data you've collected. So the use of large language models to speed up that process, I thought, was a very nice innovation. You always need the expert, but you can take away a lot of the burden on the expert and let them focus on what they do to really add value to those bulletins. So I think that was great to see. I think what I appreciate generally about this type of webinar is that you're sharing practices and determining what methods work best. And I think that kind of south-south knowledge exchange really does help identifying good standards, good practices, and seeing how you can mutually learn from the different experiences you've had with area estimation, yield estimation, pest and disease identification. Some things that are commonly applicable everywhere, others that need more specific tailoring to meet the needs. But that's really what I took away from, I think, quite an enlightening example of integrating this kind of Earth observation-based tech. And of course, that moves on nicely, I think, to the training and human capacity development that's needed to really take advantage of this digital infrastructure that's now widely available, providing Earth observation-driven insights for food security and early warning. So thank you very much.
Thank you very much, Andy. Thank you for staying on time and for this very to the point comments that will also help us to transition to the discussion and Q&A after the presentations. Now moving on to Lorraine Ronke, who is our global lead for Lorraine, I'm sorry. Who is our global lead for science, knowledge, and innovation in agriculture and food. And in this pioneering role, Lorraine leads the effort to scale science and innovation into the World Bank portfolio and into the evidence basis of policy dialogue. Lorraine, over to you. We cannot hear you. We can see you now, but we cannot hear you now. Let me see if I can unmute you on my side.
Can you hear me now?
Yes, yes.
Great.
Yes.
Yeah, somebody is muting and unmuting me, so sorry about that. It's kind of not under control. All right. My name is Lorraine Ronke. We used 5 seconds, I'd like to note, of my time trying to overcome technology. Yes, thank you so much for inviting me to be discussant. So for those that don't know, I am now the global lead of a new thematic at the World Bank, which is about scaling science, knowledge, and innovation. And so I'm going to exceed my remit, but not my time allocation, a little bit by going beyond capacity building and talking about what else it takes to take such effective and innovative initiatives like the one that we have heard today to the last mile. You know, as a Canadian, I feel like I should say last kilometer, but the expression is the last mile. So you have, you know, the technology developers, the innovators bringing it so far, and you have the folks on the ground that are the object of all of our efforts. And there's this sort of like last mile here. And I really felt that the 3 speakers today showed an awareness of that and kind of moved closer together. And I really wanted to commend that. In particular, Dr. Miao, CropWatch is an amazing geospatial tool. And it's interesting to me how you have tried to meet end users with this focus on what you called decision-ready products. You know, how are those products developed is a question that I have. You know, is it co-created with the developing country partners, or is that even something of interest? Because I think it's already something, and I think a good model for other innovation communities that we work with, that CropWatch has thought about expanding the end users. And to expand the end users, you either have to invest heavily in capacity development or meet them where they are. And I felt I was really interested by what you were saying about those decision ready tools. And I'm wondering about the role of co-creation therein with the developing partner countries. And I also really value the presentations from Malcolm and Tatiana about, you know, how we take this. I mean, if anybody's close to that last mile, it's you, right? And I thought it was really interesting, Malcolm, when you flagged the problem of knowledge sharing and coordination, because that's exactly what lies in that gap about which I'm speaking. And I also felt that you really well articulated ways forward that we could all learn from together in terms of awareness creation with the Ministry of Ag, with ATI. And most interesting, I thought, and I would love to hear more about that from you, is this idea of joint projects in order to solve kind of that coordination failure. And I'm just thinking, you know, I imagine that that's with extension and advisory, that perhaps having them lead that last mile where you speak about CropWatch specific tools. Again, it's the same question I had for Dr. Miao. You know, what is the role sort of the final end users? This could be extension agents or farmers, women and youth in developing those sort of CropWatch specific tools in that last, now we're not even in the last mile. In the case of Ethiopia, we're in the last sort of quarter mile. And similarly in Madagascar, Tatiana, you spoke really of an inspiring kind of advance in your country, and it seems very important, the applications that you are using right now. And we're a little bit upstream in Madagascar, so I was wondering if you had a little bit more on the integration of what you're doing with extension and advisory services institutionally in terms of learning. So to build on what Andy was saying, yeah, of course, capacity building is super important. But if you really want to sort of close that gap as much as possible, I guess all my questions revolve around how the end users inform on your efforts to bridge that gap. I learned so much today. I really think that not just sort of the bank that has things to offer. It's very much a knowledge partnership, and that the efforts that you have made in each of your presentations and what you were saying to close that gap, I think, are very important lessons that we should maybe share more broadly. Thank you very much.
Thank you very much, Lorraine. Very to the point comments and good questions to lead us in the discussion. And I also very much liked how you're saying how you said that CropWatch helps to increase the number of end users, and there are two pathways to do so. And we often talk about capacity building, but also you're mentioning that meeting where they are with the advances of the technology. And I feel like also proliferation of AI technologies would help us to do that as well, also when it comes to the delivery of extension services to farmers. So let me open the floor to our speakers to see if they would like to react to our discussants' points and also to Lorraine's questions. And then we can take this discussion forward. Let me know if anybody wants to come in.
Okay, maybe I can go first.
Thank you, Mia. Go ahead.
Thank you for your question, Lorraine. Very good question related to the decision-ready products and how it is developed. Actually, we are still on the way, I think. In the past, we do provide corporate information and make it freely available for everyone in the world, but we just provide the information using satellite technologies. And why I say decision-ready products, this is exactly a co-design mechanisms. So during the capacity building or training with the developing countries, different agencies, different countries, they will raise up different demands, specific demands, depending on the like strategic crops for each country and the specific management or cropping practices. All the situations are different. So after the capacity building, we work with each country or each agency together to understand their specific requirements, and then to co-design a work program or let's say a work plan to further customize the system to meet their demand. And we also always organize stakeholder meetings so that not only the technicians, but also the high-level decision makers, they join those stakeholder meetings so that not only technicians could use the system to generate the geo or yield-based products, but also to generate easy understandable information that the policymakers could easily pick up the information and make decisions, or with some additional consultation, they can make science-based decisions. So this is how we work together with the countries, or usually people call it co-design process, and to provide this kind of products. But honestly, only part of the information is decision ready. Still, there are a lot of information now is still geo-based or yield-based products, but we try to have a closer communication with different users so that we can meet their specific demands at different levels. Thank you. I hope I addressed your question.
Thank you very much for that detailed answer. So now over to Mulkamo, if he would like to reflect on how bringing the crop watch bulletins and crop monitoring results closer to the farmer, and especially those that could be less advantaged in getting that information, so youth and female farmers. Over, thank you.
Okay, thank you so much. Actually, we do have a governmental funded government here in Ethiopia, which is satellite-based data analysis for crop yield estimation, especially in wheat irrigated area. It's a part of Ethiopia region, what we call in Afar. That area is a pastoralist area, which didn't have any other croplands for piloting area. It is very close for crop watch system. Just it was very nice to detect only irrigated wheat area is known at the site, so that we could identify it by satellite data first. We do have our own proposal first before we join a crop watch system. We do have our system. We do have our own system before, and then we could identify the cropland as wheat irrigated area only. Then we could upload that area of wheat irrigated area to the system. Then we have tried to generate a bulletins for that area, because when we collect a grounded data from that area, the GVG and the field watch can geolocate the real-time data of crop growth of that area in the entire of that wheat irrigation area, so that we can generate a type of field or sorry, we could identify that area as wheat irrigated area only. Then we go for yield estimation on the basis of crop watch system, and then we can detect a bulletins of that crop area, which means the phenology of that area in the entire of the study. Then we can determine throughout the NDVI time series of wheat irrigation area in the system of a crop watch. Then we can go for a calibration in by using the mobile tools developed by crop watch system. This is what I want to say.
Thank you very much. And Tahiana, if you would like to come in to react to Lorraine's question. And thank you to Lorraine for posting that in the chat. So what are the plans for integration with ag advisories and taking advantage of where you're upstream in the process? Thank you.
Thank you. Thank you. As I wanted to say for this, what are the plan? As I thought, as I think, it's better to make a structure for the inside the ministry, because for collecting data, we are few on our center for collecting the data on the 2023 region. So the plan is to share the knowledge for the region technical person for collecting the data, and they will send to us the points, the field data, and we can process the work using this to process the calibration of data, and we can get some a good result for this report work.
Thank you very much, Lorraine. Don't know if you have any follow-on questions, so if we can move on. Thank you. So I would like to ask the audience if anybody has any additional questions. Sunil, I cannot see the participants, so I would let those who might questions in, if there are any raised hands. And if there are none, so I assume there are none. Sorry, I cannot see the participants from my side. So we have about 6 minutes left, and I would like to use these 6 minutes productively. So we are trying to, from also our World Bank side, we are trying to scale up our support for the partnership, for the partnerships that were highlighted today. And once again, thank you very much for your rich presentations and for your reflections about the challenges and steps forward. What I would like to hear from reflecting on, the experience of this pilot. I would call it pilot because it was still a lower scale that we would like than we would aspire to have. To offer a couple of pointers, and again, taking into account the limited time we have, on identifying what are some of the one or two key challenges that the next phase of engagement could address, and then also one or two sort of aspirations of where we could go as the next steps that are feasible and practical, yet beneficial to both parties and to the countries. So if you don't mind reflecting on that, I would let Tahiana come in first. We'll switch the order a little bit, and then we'll finish with Miao. Tahiana, if you have some reflections on, once again, what are some of the most pressing challenges that could be corrected in the next phase of the partnership, and then also what are some of the additional areas that are sort of the low-hanging fruit, but that's still very useful for advancing this work that you could recommend from the side of Madagascar?
Thank you. For me, it's
yeah. If you'd like, actually, maybe somebody, if you need a couple more minutes to think about. So if anybody else would come in, Malkamo or Miao, if you'd like to come in.
Maybe I can talk about some challenges, and because we've been working closely with about 26, 27 developing countries, and sustainability is one of the key issues. So we provide some trainings for technicians from the Ministry of Agriculture. After 1 year, the colleagues left. They left the ministry. They join another agency, or they leave the position. But before they leave the position, there's no transition of the knowledge they learn to the new technicians. So sometimes we have to provide training again and again. So this is one of the key issues, and we don't know how to better solve this, but we have some experience. We encourage some colleagues from developing countries to apply scholarships to study in our team for several years, so that they have a holistic understanding of the technology. And after graduation, those students, they went back to the country, and then he could be a knowledge provider to, and also as a bridge to link the country and our team, so that the connections, the sustainability could be more could be strengthened. So Malcolm is one of the example, and in the past, Jose Bufana from Mozambique is another example. So Malcolm just applied the PhD scholarships, and I hope he will join us in CropWatch for the PhD study in the following couple of years. And after that, he could be really a knowledge person, and help the country, the Ministry of Ethiopian of Agriculture, to sustain these kind of efforts and further benefit the country.
Thank you very much. This is a very important point. And so the sustainability of this work, this is also something we struggle about on our side, and particularly in maintaining that capacity at the country level. Tahiana, Malcolm, would you like to come in with any remarks from your side? We have about a minute over, but we can go over a couple of. Yes, please.
Thank you very much. Actually, I don't have any more suggestion, but in case of Ethiopia, as I have said, there is several problems like during yield prediction, especially in calibration issue that needs some refinement. I will talk with Dr. Miao. So far, I tried to calibrate my results. That the result should be oscillates when the calibration data uploaded to the system, but I could not did that one. I will talk with Dr. Miao and the team. And the more we need some support from you all in capacity building, both in scholarship systems. As Dr. Miao said, I already applied for my scholarship in Cropwatch system. Just I'm waiting for good to join them, and I will upgrade my capacity in the system of yield prediction on the satellite basis, and the more I can more perform in different application areas than the Cropwatch system with Dr. Miao and the team. Thank you so much.
Thank you very much, Milcom. Any insights from Tatiana's side? And once again, we're over time, but we can go a couple more minutes over. So Tatiana, please.
Yes, thank you. A challenge for Madagascar, it is to use remote sensing data and to share with the technical person the importance of using remote sensing data, as Dr. Mio said, like find the scholarship, how to share this knowledge, because we can left this remote sensing right now. Because I said that because he said the Ministry of Agriculture, who is agriculture takes a place very important in Madagascar. So it's better to use this remote sensing data. And it's only me who has an experience with remote sensing knowledge. So I want to share this knowledge for our colleagues, and to helping us, and to focus on remote sensing data, and for we can go quickly for developing the agriculture data. So that is my thinking. So thank you.
Thank you very much. So yeah, we hear some of the consistent messaging about the need to build up the capacity and then maintain this capacity at the institutional level. We are over time now. Thank you very much to all the speakers for the presentations, for all the attendees who stayed active with Engage. And this is once again very exciting topic. We'll continue this conversation through our webinar series, but also through our engagement with the countries, with the Cropwatch, and explore how we continue supporting such partnerships across different countries in the world. With that, thank you all, and enjoy the rest of your day or your night or your morning, wherever you are. Thank you. Bye.